In this lesson, we'll finish up section 1.2 of the McCloskey book. So we'll need to talk about two things in this lesson. First, we'll start out with a review of basic linear algebra. Now, when I say linear algebra, I'm referring to high school algebra as opposed to the 200 level college course. And secondly, using our review of basic linear algebra, we'll discuss the mathematics of budget lines. Before getting started, I'd like to quickly mention that what we're going to be doing is not comprehensive. We're not going to be doing a full treatment of all of algebra. I'm just going to be picking and choosing a few topics that are fundamental to basic economics. Now, if you want more of a review, I would suggest going to either of these two sites, Purple Math or Khan Academy. And if you want to learn this material from scratch, if you have not seen this material in the past, the best textbooks I have seen for algebra can be found at artofproblemsolving.com, which makes great textbooks for a variety of mathematical topics. Let's get started with the math. There's three main objects that we'll be talking about in our economics. These are points, line segments, and lines. A point is simply a dimensionless object in space, and we denote it using a circle. Now you'll notice that I'm denoting this object in reference to this two-dimensional plane. And I draw this two-dimensional plane using these two things. Now these two are lines, and these lines that are used to draw our plane are called axes. So, for example, I could have cars on this axis and bikes on this axis. And what this would say, if this is 3 this way and 4 this way, is that this point represents 3 cars and 4 bikes. So we represent this point's location using an ordered pair. This ordered pair is an instruction of how to get to this point, and this instruction is being made in reference to this red point over here, and the red point in the center is called the origin. Its coordinate is 0, 0. Now the other objects that we'll be discussing are line segments and lines. So a line segment is simply a straight object of finite length, and a line, on the other hand, is an infinitely long object which is straight. We draw arrows on the line to denote that they are of infinite length. Now you might notice that the axes here, here, and here do not have arrows but are of infinite length. They are lines. So a lot of times I'm not going to be drawing arrows on the lines, but you should be able to figure out in the context of what we're talking about that this object is in fact a line, and I will never be drawing arrows on the axes. I'd like to mention one more thing about the axes. Because cars are being measured on this axis, we call this axis the cars axis, and because bikes are being measured on this axis, we call the axis the bikes axis. However, this axis may also often be called the y-axis, and this axis may also often be called the x-axis. And the only reason for this is simply out of mathematical convention. Usually, when the variables being measured on the axes have no real-world significance, they're arbitrarily given the name x on this axis and the name y on this axis. So similarly, this may be called the x-coordinate, and this may be called the y-coordinate. Though we've given an intuitive idea of what a line is, you might wonder what are more rigorous definitions of a line. Well, a line is simply defined as a set of points described by a linear equation. Now, a linear equation is simply an equation with only constants and single variables to the first power. Now, these single variables may also be multiplied by a constant, but there can be no other variables with them multiplied together, and all variables must only be to the first power. So if we consider some equations, we can see quickly that this equation is not a linear equation because there are variables raised to more than the first power. We can also see that this equation is not a linear equation because over here y is being multiplied by z, and we need to have each variable on its own. This equation, on the other hand, is a linear equation. You have three variables, x, y, and z. They're all being multiplied only by constants and not by other variables, and then you have a scalar term at the end. So this is a linear equation. Now, most of the linear equations we'll be working with are only the two-variable case, so they might look something like this: 4y plus 7x equals 12. Lines and line segments have certain properties which are often useful to think about. These are distance or length and slope. So if we have 2 points and we want to find the length of the line segment between them, we might consider the distance between the 2 points. In addition, another property we might be interested in is how quickly the line segment rises as we move along it in the x direction. In other words, we might consider the ratio of the rise over the run, where this is the rise and this is the run, and we call this ratio the slope. There are some simple formulas to get the length of a line segment, or the distance between any 2 points, or the slope of a line segment or line. The formula for distance is right here: square root of y2 minus y1 squared plus x2 minus x1 squared, where x1 and y1 is a point, and x2 comma y2 is a point. This distance formula is derived from the Pythagorean theorem. If you're interested in that, I would suggest going to the Purple Math website, where they give a great discussion of the derivation. And the slope formula is right here. It is y2 minus y1, which is a rise, over x2 minus x1, which is a run. The reason that slope is so important, or at least one reason why slope is so important, is that if we know a point on a line, so here's our graph and we know 1 point, and we know the slope of the line, so we know how quickly it rises. Maybe it rises that fast. Then we know every single point on the line, because we can draw a line rising that fast through the point which we know. So we get the entire line. There are 2 particular points on a line which are very important. These are the x-intercept and the y-intercept. The x-intercept is the point on a line at which the line intersects the x-axis. So this point right here, for the black line, is the x-intercept, and analogously, this point right here is the y-intercept. Now for this red line, we have a special case where the x-intercept and the y-intercept are the same, the origin. There are 2 particular ways of describing a line which immediately give us information about the intercepts of the line and the slope of the line. These 2 special line forms are called the slope-intercept and the point-slope form. The slope-intercept form is called exactly that because it immediately tells us the slope and the y-intercept. In this equation, the slope of the line is m, and the y-intercept is 0, b. The point slope form immediately tells us the y-intercept, y1, the x-intercept, x1, and the slope, m. The y-intercept is 0, y1, and the x-intercept is x1, 0. We've talked now about all the math I plan to cover, so hopefully with your jogged memory, we'll be able to try some economics questions. So let PA be the price of apples, PB be the price of books, QA be the quantity of apples, QB the quantity of books, and Y the income. I want you to write the equation that describes the budget line for apples and books, but I want the equation to have Y, income, alone on one side of the equation. Secondly, I want you to write the same equation again, but have it in point slope form that we just discussed. So pause here and try to think of what these equations are. To answer this question, we need to think about what a budget line actually is. A budget line tells us all the ways in which we can use up all of our income on only books and apples. So let's think about, generally, if we were to buy some amount of books and apples, say 3 and 4, how would we know how much money we are spending? Well, we would multiply the amount of apples we bought, 3, by the price of apples, and the amount of books we bought by the price of books. So we would get PA times 3 plus PB times 4. So generally, for any given bundle, the amount that we've spent is PA QA plus PB QB. Now, the budget line wants us to use up all of our income, but not to buy more than our income and not to buy less than our income. So the equation for the budget line is that the amount that we spend, PAQA plus PBQB, is equal to Y, our income. From this equation, we can easily get to point slope form. I'm going to assume that apples A are on the x-axis. So the first step we take is to subtract PAQA from both sides, leaving us with this. Second, I divide both sides by PB. So I get QB equals Y over PB minus PA over PB QA. And I'm done. I've gotten to point slope form. There's a couple of interesting things that we can get out of this point slope form. First, you can notice that the slope of the line is minus PA over PB. And if we take the absolute value of this, we get exactly the relative price. In previous lessons, I've tried to hammer in that the slope of the line is the relative price of good A in terms of good B. So it's really interesting that the mathematical result is the exact same intuition. We also know from the point slope form that the y-intercept is y over pb. The y-intercept, economically, is the most amount of good B that we can buy. So we know exactly what that amount is. Similarly, the x-intercept is y over PA, the most amount of good A that we can buy. That's all the economic intuition that we can get out of this simple example. But I hope it's shown you how a little bit of mathematics can be very helpful in understanding economics. So that's all we'll be getting out of section 1.2. For next time, I'd like you to read all of 1.2, do exercise 5 and problem 2 in section 1.2. So I hope you enjoyed this lesson, and I'll see you next time.